Hello, my name is Taylor Phillips and I'm the owner of Hole EcoTour Adventures. And I'm super excited to be here with you today in a partnership with Toms of Maine and their Nature Nurtures program. Today we're going to be exploring northwest Wyoming and the greater Yellowstone ecosystem and bringing nature to your homes when we need it most. So please join me as we explore the natural world. We'll be exploring certain species of wildlife, the Teton Range geology in this 10-minute session. So yeah, come with us and I hope you enjoy it.
I hope you can hear the river behind me. We're along a western river here in northwestern Wyoming, talking about beaver, ecosystem engineers. Beavers, they're known as engineers as they fell trees, create dams, and impact waterways, which provides habitat for many different species. Here in Wyoming, only 2% of our land is riparian. Riparian is the habitat associated with water. Beavers help create more of that habitat. So hands down, because we have beavers, we have more waterfowl, we have more moose, songbirds that enjoy the willows that grow next to waterways. Beavers, they're something else. Check this out. So this is a beaver felled tree. So beaver, they have two large incisors that continuously grow. You can see the individual teeth marks here. You can see the chips at the base. Beavers, they fall trees like this to access the upper branches so they can enjoy that cambium layer, that bark. That's the nutritious part of the tree. They're going to eat that cambium layer. That's their nutrition. They'll also eat grasses, aquatic plants, and other vegetation. But this time of the year in the spring, cambium is where it's at.
In northwest Wyoming, there are 4 species of the deer family: elk, moose, mule deer, and whitetail deer. Often on tours, we do get the question, what's the difference between the mule deer and whitetail deer? And for a lot of folks, they're very similar looking animals. But if we look closely, we can find many differences. For one, mule deer, they are a larger, heavier, slightly stockier deer than the whitetail. Also, the coat color. Mule deer, they do have a grayish brown coat, whereas whitetail deer typically have more of a reddish brown coat. And if we look at their antlers, male members of the deer family grow antlers. Every year those antlers do fall off. Mule and whitetail deer are no exception. Mule deer, they have a branching antler pattern. So the antler comes out of their skull and then branches again, maybe even a third time. Where whitetail deer, the antler comes out of their skull, one main beam, and then there's small tines that come off of that main beam.
Moose, ailses, largest member of the deer family. Large males here will stand 6 feet or so at the shoulders. You can tell springtime is a tough time for these individuals. Traveling on top of the snow, breaking through, doing what they can, just waiting for spring green up. When spring green up occurs, then these animals, their antlers will grow at a quick rate of up to 1 inch a day. Antlers are used during the breeding season primarily for mate selection. Males will advertise their antlers, the size, the symmetry of these antlers. It's a great indication of an animal's health and fitness. Animals that typically are older, have good access to food, are healthy, will grow the largest antlers. Females see that, and it's thought that the size and symmetry of the antler helps with mate selection. Antler, it's a calcium, similar to our bones. And every year those antlers do fall off. If a particular male deer if they would have a poor year with forage, or maybe they're injured, that antler will fall off, and next year they'll have another opportunity. I just love seeing this new antler growth. That's fantastic. Look at those long legs. You can just imagine when that animal falls through the snow, those long legs will enable them to kind of step forward and move through the snow. The moose, they are found around the world at northerly latitudes. They're long guard hairs, 3-4 inches long or hollow, and those hairs really help trap heat next to their body. And then underneath those guard hairs, they do have a downy underfur, which is excellent insulation as well. Moose are ruminants, like cows. They have a 4-chambered stomach, and the food gets passed from chamber to chamber to chamber, where there's different species of bacteria and other organisms that help break down the cell walls of the plants that they're eating. So then the animal can then digest the organelles inside those cells, as well as digest some of the bacteria that's feeding. Rocky Mountain Bighorn Sheep. Males identified with their large curled horns. Females, smaller horns. Horns, very different from antlers. Horns typically never fall off. Both males and females grow horns. Horns are made out of keratin. That's the same thing that your fingernails, your hair, their hooves are made out of, where antlers are bone and do fall off. Bighorn sheep, they have excellent eyesight. That's why we typically see them out in the open, as well as we see them in areas where there's quick access to steep, craggy rocks. When predators are seen, whether it's wolves, mountain lions, bighorn sheep, they're known to run to those rocky crags and position themselves on the steep slopes where those predators can't access them. The bighorn sheep rut, the breeding season, occurs in this part of the country early December. Before that, these males are establishing dominance within their male groups. Male sheep will display their antlers, display their body size, and if there are similar size animals competing, they will stand 30, 40 yards apart from each other, run at each other at 25, 30 miles an hour, and at the last minute stand up on their hind legs and then clash horns. Sounds like a rifle shot. Male sheep, they'll clash sometimes 10, 12 times an hour until an individual starts feeding or backs off. Bighorn sheep are very well designed for this behavior. Their horns could weigh up to 5-8% of their total body mass. And their skull, their frontal skull plate, is a honeycomb material with special layering to absorb some of this blow. The Teton Mountains, one of the youngest mountain ranges in North America. 250 million years ago, this area was flat, covered by shallow seas, receding waters, mud and sand. 65 million years ago, the Rockies uplifted through crustal compression. The Tetons, even though we are within the Rocky Mountain region, the Teton uplift is not associated with the Rocky Mountain uplift. After the Rockies were uplifted through the crustal compression from the ancient Pacific Ocean plate, there's been crustal extension from the lack of those compressional forces. And that crustal extension that has been running east to west has formed cracks that run in the ground, that run north to south. Those cracks known as faults. The Teton Range is a normal fault block mountain, and most of the uplift occurred just 3 to 5 million years ago through a series of earthquake activity. These mountains are still rising, about a foot every 500 years. No earthquakes since human settlement in this region, but geologists are expecting earthquakes to come. The mountains here, they've been sculpted by many different episodes of glaciation that have helped create the look that you see today. The Grand Teton, it's a beautiful version of an arête. Just imagine glacial ice on each and every side of the Grand, eating away at the rock from those different angles, giving us those sharp edge ridges, the sharp peaks, and sheer cliffs. The mountains are still growing. We have a very hard, very resistant rock. And the different episodes of glaciation have carved them and make them look the way we see them today.